So now we're going to talk about the plum pudding model and how our idea of the atom has eventually evolved into what we believe now. The plum pudding model is this: Thomson at one point discovers that electrons are very small particles inside of the atom. That they're very small. They have a big chunk of charge, but relatively small. So he believed that the rest of the volume of an atom, okay, so think about the volume of that atom, is filled with a fluid-like material that had a positive charge, okay? So in the case, let's say, of hydrogen, the hydrogen molecule was nothing more than this big blob, and inside there you had a chunk, which, mind you, is not even close to being drawn to scale, and of an electron, okay? So this is the entire volume of the hydrogen atom with one small piece here for the electron. And once again, that's not even drawn to scale. That you understand that that electron is even smaller than that. That's maybe the nucleus. And that is probably even too big. Okay? So that's the plum pudding model. So the mass, the majority of the mass of the volume, small floating charge over here, very, very small compared to the overall volume of that. Okay? And because of this gooey kind of jelly property, that atoms simply bonded to each other because of that positive charge, because of that fluid. It's just like taking a raindrop and putting it next to another raindrop, and then another raindrop and another raindrop, over and over again with these really, really small chunks. So that was the plum pudding model. Now, to test whether that model was true, we fired an alpha particle. You remember from radiation what an alpha particle is? And it has two neutrons on it. It's relatively small. It was a high-density object that we could fire through there, and it would go, we believed, that particles would do there. Once in a while, experience a minor deflection, okay? But nothing of any substantial, anything major. So the plum pudding model, you've got this gelatinous kind of positive charge pouring around. You have these small chunks of negative charge. We tested it by taking a piece of gold, flattening it several atoms thick, and firing alpha particles through it, expecting those alpha particles to basically travel around here. So you have a counter that's counting where those alpha particles strike. It's just a piece of film, to be honest. Okay? We find out, though, instead that most particles just travel straight through like we expected, but we had major deflections occurring. Okay? As they travel, as every once in a while a particle would travel through and get these major deflections, which most of them just travel through without any problem. But every once in a while you had a major. So that destroys the idea of the plum pudding model, because what that means is that you have an alpha particle coming in high density, high charge, striking something of even more density and even more charge to be deflected back on itself, which doesn't follow this model. Okay? There isn't any argument for a high density, a high mass, high charged particle to be sitting somewhere inside that plum pudding. Okay? So, the plum. So Thomson discovers the electron, the charge ratio electron. He develops this model of the atom using basically what we know about the universe, volume. And inside that volume we have spread across the entire volume. And then it's later tested by Geiger and Marston and proven wrong. Okay? Now Geiger and Marston were sponsored by a man by the name of Rutherford. Rutherford is an interesting person in history, and the fact that he's kind of a philanthropist. He liked to support experiments. Okay? He liked to further science. So he would pay for these experiments to happen and see what happened. Okay? So Marston, Geiger disproving the plum pudding model of Thomson.